everybody. Welcome to OpenCV Weekly Webinar. And today with me is Edgar Riba, who is the primary author of Kornia. It's a upcoming library now gaining a lot of popularity in the PyTorch community. And Kornia is a differentiable computer vision library. And if you don't understand what that means, Edgar is here to explain all about it. Edgar, a quick intro, and then we will go over Phil Nelson.
Okay. Thank you so much, Satya and Phil, to invite me here. Yeah, I'm very glad to be here to explain everything about Kornia. We can discuss about this hot topic, differentiable computer vision that is happening right now. And as Satya said, I'm one of the main co-authors of the library Kornia that I started a few years ago with actually Gary, one of his companies. So and about myself, I've been contributing to also the OpenCV community for a while, helping with mentorship during the Google Summer of Codes. And that's it.
And also directionally, I mean, you have been part of the OpenCV community for a long time. You're there in all the technical meetings, etc. In helping us quite a lot. And I wanted to say we will go over to Phil Nelson, not go over Phil Nelson, but so Phil is our content manager at OpenCV. He is responsible for putting together the webinar. Welcome, Phil.
Hey, Satya, and welcome everybody. Thanks again for joining us. There's about 100 of you here already. We really appreciate it. As usual, we will be doing a giveaway at the end of this episode. You really want it. It's going to be for the new Kickstarter campaign that we're launching on the 15th. So stick around for that. We'll also be doing a live Q&A with you in the audience. Please use the Zoom Q&A functionality to ask your question at any time during the webinar, and we'll answer as many as we can at the end.
Yeah, just to show what the giveaway is, it's in this box. It's the most exciting thing we have done, and it's going to be, I think it's a very big deal in spatial AI. Last year when we did the Kickstarter for OAK-D, OAK-D was the Porsche of spatial AI edge devices. And this one, we are calling it the Model T of spatial AI devices. This is a device for everybody. And it's very exciting what we have been able to do with just the price. We are breaking a price barrier this time. It's going to be very exciting. So watch out for this device. The Kickstarter campaign starts on the 15th, and maybe it will run for a month or so. And I can show you what's inside the case. But later maybe I will give you a little, not a sneak peek. I'll just show the inside of the box to show how little the device is. So Edgar, let's get started. You can share your screen and let's get started with the presentation. Welcome, everybody.
Okay. Can you see well my screen?
Yeah.
Yep, that's great.
Good. So again, thank you for the invitation of these webinars. I think you're doing a great job here. So I'm very happy to be here. So actually, this is one recurrent talk that I've been giving while I've been promoting the library. I call it Differentiable Computer Vision, which is an introduction to Kornia. So myself, I'm the co-author of the library that I started in one of the internships, one of the companies that I was working with Gary. And then later I continued this project during my PhD. Then other colleagues of mine joined the effort. And this is what Kornia is right now, which I'm going to explain, Okay, so let's start. So I usually put these slides because, just to be aware, more or less what we are talking here, and usually not everyone is really aware of what's computer vision. So here, I guess everyone will be more or less familiar with these terms since we are in OpenCV webinars. But yeah, just to remind, basically what's computer vision, that it's this area of techniques to get a high-level understanding from images. And yeah, and also taking into account that in the end, images are not more than matrices, or even now it could be understood as tensors, as we will see in Kornia. So to give a little bit of context here, and that's how we more or less approach it or decided to start with this project. Is that for a long time there was this diverse ecosystem of different libraries implementing classical computer vision using different technologies like Python, C++, more recently implementing all these algorithms with NVIDIA CUDA, OpenCL, and also starting this past, let's say 4 or 5 years, all with this all deep learning hype, frameworks like PyTorch, TensorFlow, intermediate representation like ONNX. But since our focus was all the time computer vision, it's a fact that OpenCV was kind of the center of this computer vision universe in terms of libraries, even more for the open source side. But what happened here? So as I said, we started to approach this deep learning area, and at that time, we had this discussion in that small room at Array with Gary and Ethan, and we asked, hey, what is classical computer vision here, in deep learning? And the answer to the question was, hey, maybe there is a black hole area here, because when PyTorch came out, there was Torch Vision that was implementing some transforms. They started to include some models, but we didn't have in the ecosystem like a proper library computing, implementing all these classical vision things. So that's more or less the reason of Kornia.
Just to summarize up until now, what you're saying is that earlier, before, let's say, 2014, 2015, we just had traditional computer vision, what we call as traditional computer vision now, which is the pre-deep learning era, right? Where OpenCV dominated when you thought about computer vision, it was all OpenCV. And after that, all these libraries, TensorFlow and PyTorch started coming in, and now there is this deep learning ecosystem. It is being dominated. Deep learning is dominating many aspects of computer vision. But people think of them as two different things: traditional computer vision and deep learning, and the techniques don't go hand in hand, right? You are either using a deep learning technique or you're using a traditional computer vision technique. And Kornia is trying to kind of make computer vision techniques or computer vision aspects differentiable so that these two things can, talk to each other in the same framework.
Yeah, actually, one sentence. I would like to mention here my colleague Dimitro. I think that he has this even in his LinkedIn that, in Twitter, that he's saying that we are marrying the two worlds of classical and deep learning. So and in a sense, you can think of Kornia like the bridge between classical computer vision and deep computer vision. That's more or less the whole idea. Okay, so now I think that it's more or less clear what Kornia. So yes, Kornia, we define it as an open source differentiable computer vision library for PyTorch. which means that, yeah, as I said, we started this project. One of the ideas was to re-implement all the classical vision algorithms in terms of differentiable tensors using PyTorch. So actually, just as a curiosity, we started this project as a small package, actually called torch geometry. So at the very beginning, Kornia was just a specific small package implementing all these geometric image transformations, which then eventually, I think at some point we discussed, Satya, I asked some recommendations to you, hey, how we can scale that to a more generic vision thing. Yeah, so we did it.
I remember discussing the various names you had, when you were changing the name from torch geometry to Kornia.
Oh man, Dish, I need to know what some of these other potential names were.
Well, to be honest, I don't even remember right now. But
I guess they couldn't have been that good then.
Yeah. So actually, Kornia, well, a lot of people is asking me, some people guess, but Kornia refers to the cornea eye. So I played a bit with the letters and this game word. So that's more or less the meaning of Kornia. And as you can see, also the logo, it's like an adaptation of OpenCV plus at that time array logo. So okay. That's what it is at Kornia right now. Yeah, so as a summary again, so Kornia, in Kornia we implement all these classical vision things using PyTorch. And then, as I said again, just to be clear, so everything here in Kornia, it's implemented from scratch. I will go after this topic because actually one of our golden rules is that it's only PyTorch. We don't have dependencies inside the library, so everything is implemented from scratch using PyTorch. So that's why I think that the library is very powerful, because we take into account inside PyTorch can give us. And also one of the ideas, and that's why we all the time have been very aligned with OpenCV, that in the end, Kornia, we want also to offer these created vision algorithms, be ready to be used for the community. Yeah, and then as core features, something that we like to mention. So yeah, Kornia, it's basically meant for computer vision, differentiability, but also we take all the advantages from PyTorch, like that you have a transparent API, meaning that it's agnostic to the device. So you can run the same algorithm by just passing a different device. So you can run in CPU, in GPU, now in TPUs, and I guess in the future, I mean, you could use it in more sophisticated devices. Also, the parallel programming. So we adapted all the algorithms to be run in batch. So you can make it more efficient. For example, when you work with data sets, or for example, a concept that we introduce here, it's for example, to perform the data annotation also in batch, right? And finally, you can combine.
Does it mean that suppose you're not, let's say you're not even interested in PyTorch, you want to do some computer vision stuff, you could simply use, and you want to use the GPU very easily without having to worry about anything. So you write this code in Kornia, right? And it has all the power that PyTorch provided, right? And you can do all these operations onto the GPU or any other device you want. So you're basically piggybacking on the nice things that PyTorch has provided, and you can implement your algorithm that way, even if you're not using PyTorch.
Yeah, that's right. So the API that we're using, I mean, it's totally agnostic. So everything actually it's encoded inside the tensor, right? So if you provide to the a tensor that it's hosted in a GPU or in a server, it doesn't matter for you. As a user, you can still use it. You can switch from different devices. So yeah, and that sense.
And also, the batching is very interesting because now you have a batch of images that you can send all of them together to the GPU, get it processed, and get it back in one shot. So it can be very fast.
And not only that, but also the 2 points that I was missing, distributed. So you can use it also with the API, the distributed API from PyTorch, and the magic is all done by PyTorch, and you can have different servers and different locations, and then you can run your vision pipeline distribute. And also another interesting feature is that also thanks to PyTorch and TorchScript, you can export, or compile it, all the algorithms in Python that you prototype in Python. You can TorchScript it, and later you could export it, for example, in C++ or even other languages. And this is, I think, a very interesting feature that right now we are starting to focus more. So so these are more or less the core features at high level. That's basically we inherit all these features from PyTorch. And then in terms of functionalities, so as I've been mentioning, we implement all these classical vision things so we have a strong package for data augmentation, image enhancement, color conversions. We have also a very strong algorithms for 2D feature detection. So this is funny because actually Kornia, in the end, it's just a compilation of different algorithms or things that we have been using myself or Dimitro or other our collaborators during our PhD. And we were, so our dissertations were very focused in image matching. So actually, I would say that Kornia has two main big components, which is the 2D features packets that we have there, state-of-the-art detectors and descriptors, but also in the geometric part. And besides, we implemented all these things like image filtering, so we have different edge detection algorithms. And now we start to include more 3D geometry, like different functionalities to work with structure for motion or to perform epipolar geometry. Do you have any question until here?
None from me so far.
Okay, good. Yeah, so this was more or less different features and functionality that we have in Kornia. Now I'm gonna start, to talk a bit more about our community and how we can interact or how you could start using Kornia. Yeah, so Kornia, as I said, it's open source. We are in GitHub. Right now, we have more than 4,000 stars in GitHub, and we have seen a lot of interactions there. A lot of people downloading the packets and getting more and more contributions. So then to start using Kornia, it's very simple. That's what we were discussing now with Satya before starting this call. That he was asking, hey, how you can get Kornia? Then that's easy. So you can just pip install Kornia, and then you will get the latest version. And one of the golden rules that we have in Kornia is that it's dependency free, meaning that we only support PyTorch, and this has an explanation because as I said in the beginning, we wanted to have this kind of implementation of classical things, differentiable, in order to avoid confusions in the feature, or to make a more complex the development. This is something that we said in from the very beginning. Hey, everything that we put here inside Kornia in the repository, at maximum it has to be PyTorch. So we don't use NumPy, for example. We don't use any external packages like OpenCV or Torch Vision, anything. It's pure PyTorch.
Nice.
So then more things about our community. So yeah, so if you want to learn more how we work or all the different things we do, so you can go to our website. We have this new design for the website. So we call Kornia. Yeah, maybe I would like to ask your opinion about this concept, computer vision 2.0. What do you think? Because this is so we have been like promoting Kornia, like being implementing this computer 2.0 concept, meaning actually the topic of this talk, differentiable computer vision, right? And then so the ecosystem, yeah, we started to grow. So different packages are starting to use us. Here we put just the most known ones. So Lightning Flash, now it's using Kornia for the augmentations part, to train or fine tune these high level implementations for the vision task. Also, you can use Kornia inside Kaggle. So we are part now of the Kaggle kernel, and then other packages like Catalyst or FastAI, they are integrating us. So yeah, so we are starting now like to be not everywhere, but in more and more packages. Then, yeah, if you want to learn, for example, or daily duties, definitely, yeah, just go to our GitHub. So there you will see all the different features. We try all the time to have like an open roadmap as issue. So actually, this is something that worked quite well during this last year. To have as an issue, an open roadmap with a list of the different features that we want to implement. And actually, we have seen that as soon as we put new features, a lot of people, it's just volunteering to implement. And I think that's a good signal in terms of community and to grow even more your community. Then, yeah, we have an online documentation that we recently revamped. So we included, this is something that a lot of users ask for a while, that for each of the algorithms they were asking, hey, it's cool that you have the explanation, the different parameters that you need, or even a small snippet how to use it, but hey, it would be nice also like to see the result, right? So, yeah, so we did this revamp of our documentation so that when you go to the documentation, not only you read how to use, how to parse the API, but actually see what's happening. And I think that it's very illustrative.
Yeah.
Yeah, and also the tutorials. I'm going to show later short tutorials that we have. So we have now different tutorials. We have implemented the tutorials using Google Colab, so that the users can go to the tutorials website, read it, and if they see that it's interesting, just with one click, you can go to Google Colab, and then you can start playing with different images or playing with parameters. And in the end, we are helping to the user to make them more familiar with the library. So yeah, any question from here?
So far, so good for me.
Okay, yeah. Now I'm going to more or less point the different things that we are trying or that we want to focus in the future. So as I was explaining before, so Kornia, it has now very low-level features, no, to use it as a core. But something that we are planning now is to include more high-level APIs to solve different problems that probably, if you are familiar with OpenCV, no, for example, implementations for optical flow algorithms, or even different functionalities so that you can build your systems, or even camera calibration APIs. And we believe that, for example, like areas like farming or specifically robotics, it's something that you're using a library, like Kornia, and that combined with this all the new deep learning approach, in the end can be a win-win for everyone. Some other things that we want to start to do here, it's also like to provide interfaces, like to embedded devices like the NVIDIA Jetson, and yes, OpenCV OA kit. Yes, this is something that probably we can discuss how we can make this collaboration, because I think that would be interesting also for users, like to show how to use Kornia, or using PyTorch inside the OA kit. Yeah.
Yeah.
Then so all things, as I said, related to the farming thing. It's specifically for robotics. So we have also different implementations. I think they are not merged, but we have some people working, for example, in different algorithms to detect fiducial markers that in the end will be useful for these different communities like ROS, and even now ROS2, which seems to be more focused for AI. Yeah, so that was more or less our general ideas, how we think that we will go in the future. And now I wanted to show a little bit, basically, what is Kornia in practice with this example. So for now, I've been discussing general terms, but yeah, so I don't know if the audience here how familiar is with coding in general.
Oh, they are familiar with
okay, good. So
coding, OpenCV,
yeah. So here, so this is a very simple example. Actually, this is something that you asked me before, Satya, about if Kornia is starting to be used in papers. Actually, this is one example. So we implemented this patch sequential thing because we found one paper that they were using us, some of our annotations, and then I don't recall exactly what was their use case, but they implemented this grid thing, right, on top of Kornia. And then once we found out that they were citing us in the paper, we started to contact with them, and then we said, hey, let's do an API, right, to be included in Kornia. And that's one of the cool things, actually in open source.
That's actually a very good signal when people in the academia start using your library. It's a signal that it will catch on, more and more people from academia, because that's where it starts usually. All the research is still in a lot of research is in the academia. So when you see that a lot of papers are being written with your library, then you can see that's a very strong signal that people are adopting it. Like in 1 year or 2 years, the general developer community will adopt it widely.
It's a snowball effect.
Yeah, and I mean, and I guess it's also the open source or open science effect that as soon as you are open, and you have your repository public and GitHub, it's very simple, just to go there and just open an issue and say, hey, I have this paper, I have in mind this implementation, and that's how actually we start all these collaborations, just opening issues or through maybe Slack, or we use a lot of Twitter to promote actually the different papers that using Kornia. And then it happened, I think, a few times that we promote in our Twitter a paper using Kornia, and then we started even a discussion there to say, hey, how we can make like a more robust API. It's cool that you have in your paper, you have your own implementation, but hey, let's make it more formal so that others can use it, right?
Right. Yeah, let's go over this code. I mean, this looks very interesting because with just a few lines, you're able to add data augmentation, right? Of various kinds. You're doing color jittering, you're adding random affine and perspective transforms to patches. Could you just go over the code, what this thing is doing?
Yeah, sure. So basically here, you can see that we have this patch object, which basically, so we call this a container. So that basically are objects that inherit from this PyTorch sequential object. Where we have built this high-level logic so that you can include the different augmentations that we have in Kornia, like the color jittering, here I show the random affine perspective, but we have more than 20 or 25 now different augmentations. And here in this specific example, so you can just include it in this patch sequential thing. You can combine them, whatever you want, and then what we'll do internally, it's just to split the image in grids, and then we'll apply independently, actually in batch. It will apply in batch the augmentations for the different grids. So actually it's super cool that because in PyTorch it's very simple to do that. You just take the image, you split it, you create a batch of these grids, and then you can apply in parallel the augmentations to the different grids. So I think that's a really cool example or feature that using PyTorch is very simple to use.
Right.
So here we define first this operator to perform data augmentation, and here later, if you are of course familiar with OpenCV, you see that you can load the image using OpenCV, and then we have these utilities like to cast NumPy images to torch tensors, and then again you have to do this RGB to VGR thing from PyTorch, from OpenCV to get your RGB image. And then when you have your image tensor, we call it here is the T image, you can just infer this image to this object, and then you easily get this result. So with very few lines of code, you can actually do a very nice augmentation here. And probably something that I could mention here that I was saying in the beginning of this presentation is that, so now you can have this code as it is right now, it will run in CPU. But for example, if you put in this tmatch .CUDA, it will happen automatically in the GPU. Or if you send the device, if you are using TPUs, you can send this XDLA device and it will be done magically by PyTorch in the different devices. So
that's data augmentation, but it's even more powerful than that, because let's say, I mean, the classic example that I can think about is, let's say you have a neural network and there are, you are in one of the layers, And one of the layers, for some reason, you think that a warp would be a good idea, right? So you could include a warp inside the layer. And you could, let's say you could not do that with OpenCV because first of all, it will break the graph. You cannot just take it out and put it back again. The second thing is that you will have to take care of all the differentiability problem yourself.
Yes.
Here, you can include it as part of the layer. That warping you can include as part of the layer, and it just magically will work, right? You don't have to worry about it. It will it's a differentiable layer, so it will just take care. PyTorch will take care of everything. Kornia will take care of everything.
Yeah, actually, now that you mentioned that, in fact, we have this implementation of a warp perspective, which I think it's one of the most famous functions inside OpenCV.
Yeah.
And you're right. So, for example, this operator, it's very powerful because you cannot only differentiate through the image, but also through the transformation. You can actually, you remind me that I have an example to show about that. Actually, like to register two images, and we make use of these operators. So let's probably go ahead. Let me finish. I'm missing 2 more slides, and then we can go to an example where I can show actually this differentiable thing using the geometric transformations. So as I said before, we have also different implementations for doing local features. Here, we show this example using OpenCV Sift, and we compare, for example, using the Kornia Harnet, which is one of the state-of-the-art local descriptors. We have all these implementations for local descriptors mostly. We have very few detectors. We have the classical ones like Harris. We have different of Gaussians. But to be honest, still the OpenCV Sieve detector works really well. It's difficult even now with neural networks like to find a proper method for detection. And my colleague Dimitro, he's very inside of this community, and he's saying that all the time that there is a lot of work yet, for example, to do in detecting local features using deep nets. So and then more things, classical things that we have implemented. It's, for example, all these morphological operators. And actually, something that I wanted to show with this, you can say, hey, morphological operators, no? It's something that it's already in OpenCV and other packages. But I think this is also related to what you were saying, that most of the operators in Kornia, we assume n-dimensional tensors. It's not only grayscale or RGB. We are agnostic of the number of channels of the image. It can be, as I said, grayscales, RGB, RGBA, or N, which means a tensor or features that you can get as an intermediate result of a neural network. And here, that's the cool thing that I wanted to show here, no? That, for example, we implement the morphological operators using binary, grayscale, or can be RGB, or you can even apply this morphological operator to a tensor of features. I don't know if you ask me what's what's the meaning of that. I don't know, but at least we give the opportunity, for the community to be creative, right?
Right. And also, I mean, there is little, it's just a nice to have the cognitive overload. You have to convert this thing to grayscale before applying this feature, and those things you don't have to worry about it. Just throw in the image and it will produce the result, right? So are you showing that this is working on transparent images? It's a 4-channel image, and you're getting it all the. Okay.
Yeah. As an old school Ninja Turtles fan, this is really breaking my brain. Everybody's masks are the wrong color. It's chaos. Mike's yellow, Raphael's green, Leonardo's red, Donatello's blue. This is just bananas.
Yeah. Yeah, actually, I didn't realize about that. Yeah, you have a point here. Yeah, I don't know where I got that picture because I even changed myself for sure. But yeah, that's good. So I don't know how much time do you have? Because yeah, I could go through this collab.
Let's go over a few more examples. If you have a few more examples, that would be great. We have about 5 minutes, and then we can open the open up for discussion.
Okay, sure. Yeah, so yeah, let me finish with this slide. Yeah, so again, since you know, we are trying to grow the community, so and if you are interested in joining or learning, yeah, we have a Slack channel. Everyone is invited to come there. We have different peoples more or less acting as mentors. So if anyone wants to start to implement some algorithm, just go there and yeah, we'll help you all. Yeah, and as I said, if you have the chance, also follow in Twitter, because we are trying also like to be very active, sharing the different papers that implement Kornia. But not also Kornia. So in general, we try also like to share the recent news in the computer vision community.
Do you guys also do Google Summer of Code for people who might be interested next year? Do you guys also participate in Google Summer of Code?
No, because well, we applied, but you know that Google is a very picky sometimes. Yeah, so we didn't succeed with the application. Yeah, maybe we'll try next year.
But it would have been picked if it was Facebook Summer of Code.
Yes, that's true. That's really true. No, but there are projects, PyTorch projects that got accepted.
Yeah.
Yeah. So yeah, I don't know. Yeah, you know that it's difficult sometimes to know how they measure things.
Right.
Yeah, but we will be really happy, like, to be in the Google Summer of Code or similar things. Good. So yeah, let me show here. Yeah. So this is the tutorials web page. Okay, let me first, so this is the documentation, online documentation that we have, and here, if anyone is interested, so you can go to the tutorials. We have this list of tutorials. Then what I wanted to show here is this image alignment using the differentiable transformations, which is the interesting part that we were discussing here about having the operators differentiable. Right. So basically here we show this example. In the case, let me go a bit quickly because we have a lot of code just to understand what we have here. So assuming that we have these two images, these classical images, that for the community that has been working in local features, the graffiti image. Mm-hmm. So assuming that you have these two images that are not aligning, so we have using this implementation of the warp perspective operators. So we show here how through a non-line process you can differentiate not only through the image but to the transformation, and you can easily find the transformation that maps, in that case, the source image to the destination image, and getting a result, like the one on the right side. So for those, if to understand well, here what you see in the last picture, it's the initial image transform and put on top of the other, right? This is more or less the high level understanding of this. So, and basically, so here, if you have, time go through the code, but basically what we show is that we can create this homography module. Maybe I can show very quickly this homography module that basically inherits, if you are familiar with PyTorch, so PyTorch has this basic building block called an module, where you usually implement your neural network, and all the parameters defined here will be used to be optimized, right? So in here, what we do is we define a 3x3 matrix, which is basically the homography that we need to map from one image to the other. We define it as a learnable parameter, right? So, and what happens here is that we use this module. We feed it inside an optimizer, a PyTorch optimizer, and then we have implemented this optimization loop that we did some extra tricks here to compute as a Gaussian parameter, right? And then basically what we do here, this is the main skeleton of the optimization, and we go through the different levels of the pyramid. We use this warper to take the image in the specific level of the pyramid. We warp it using this homography. To remember, this is an homography that keeps updating every time.
It's learnable. It's learning. It's updating while you're training.
Yeah. So here, and then we get this warped image, and then using the warped image, we compute a loss function, like you were training a neural network. And then finally, you can see here, well, we apply some tricks here to apply mask, to avoid issues with gradients. And finally here, if you are familiar again with PyTorch, you get your optimizer, you do the backpropagation, and then you apply the step to the optimizer, and the homography will be updated, right?
Right.
And so here, so this is the main loop through the different levels. And let me show you the results. So to understand what's happening. So this is, we start from the bottom of the pyramid. So you can see that the image is blurry. And then in the third column, you can see is the actual result of applying the homography at each step. And you can see the more we get to the end, that the image is more aligned, right? And you can see that after here, actually we need just 6 iterations, that we can see here in the end that the alignment is kind of perfectly done, right? Yeah. So, and this is thanks to this warper operator that can be used with all the differentiability properties from PyTorch.
Right.
So, and this is just a simple example. Actually, this was the first example we implemented with Ethan at that time at Array. That the homography warper was the first component of Kornia. So, but yes, other things that you could use this homography warper, for example, it's directly applicable, for example, in the case of spatial transformers. Or for more advanced things, could be really interesting. What you mentioned, Satya, that instead of getting 2 images, you want to align features, right? Tensor features coming from neural networks. And yeah, I think, these are still, I think, open areas of research. I think that, I will be very happy to see all of them, like using our framework to implement these ideas.
That's great.
Cool
Yeah,
example.
so I think
Thanks for that.
we can,
Go ahead, Satya.
if this is a good time to take questions, because people may have a lot of questions. This is, not the traditional computer vision stuff. So people may have a lot of questions, what the library does, etc. Let's get started on the questions.
Yeah, Edgar, could you unshare your screen, please?
Yeah, sure.
Great, thanks.
Yeah.
So, Plamen would like to know, do you have Kornia for C++?
Good question. Not yet. So, but so we started so Kornia based on PyTorch. So all our implementation, the code basically it's in PyTorch. So it would be like a huge effort, I think, right now to port everything to C++. But as I said before, one of the cool things about PyTorch is this new Torch script thing, which I believe that could be one way, like to have some sort of interfaces to C++. Yeah, so I think that could be, if anyone is interested in using Kornia in C++, I think that the way to go is through Torch script. So we have all the code except some operators, because Torch script is still a bit tricky. Not everything is supported yet. Like if you have some typing like union, it's not supported. But in general, I would say that 80% of Kornia right now supports Torch script. So it's very simple, like to define your function, pass it to Torch script, and then from that you can export it, I think, relatively easy to C++.
Great, thanks for that. Jens would like to know, does Kornia support exporting to ONNX like PyTorch does?
Yeah, so it's the same. Actually, we haven't tested at all against ONNX, but the way ONNX and Torch script, I think it's very similar. So once you have a defined operator, you can pass it to ONNX and it should be feasible. So we don't use any fancy things. So we use plain PyTorch. So in theory, everything should be exportable to ONNX. Yeah.
Great. Popular question. Are there any plans to make Kornia work with OpenCV AI Kit?
Yeah, that's a good question. Maybe we can discuss about that. I mean, so we are community based. So if the community asks about that, yeah, right. Let's do it.
It's worth exploring for sure.
Yeah. Well, actually, I have one question. Do you have? I haven't played that much with device. So do you have an API for that?
Yeah, we have an API for. I mean, I'll point you to it. It's called the Depth AI API, and it has a Python-based API. So.
Okay, so the next question is will be easy to use any PyTorch code there?
Well, so ultimately, I'll have to check with Brandon. Actually, I don't know for sure.
Okay. Yeah. I mean, because if this happens, I mean, if you can use easily PyTorch with this API, I mean, I'm quite sure that then, Kornia could be.
So the OpenCV, like OAKD, it's basically using the Intel's tool chains, right? So it's basically OpenVINO. You optimize the model using OpenVINO, load it, and then we have a Python library that helps you do this. So we'll have to check whether PyTorch is easily.
Cool. Yeah, will be interesting to see.
Thank you for that. McDodd, hopefully I'm not butchering these names too badly. Sorry, folks, if I am. What are the future horizons of Kornia with TensorFlow?
Again, I think it's the same as exporting to C++. So I think that, so actually PyTorch has I mean, Torch script is a very powerful thing. combined also with ONNX, I think that at some extent could be feasible. I'm not sure at which horizon, but I think that through TorchScript it should be possible at some point also to export like to other frameworks. No, as soon as you can get an intermediate representation to TorchScript or ONNX, I think that could be feasible. So that you don't have to rewrite everything or in C++ or even into a new framework, right?
Cool. Karen asks, would you please, I think you mentioned a few papers using Kornia out there, but I don't think we got the names of where they were. Would you mind telling us what those papers were?
Yeah, so we don't have like a proper list. Maybe we should do it, but now, I mean, it's growing and it's difficult to keep track of everything. But yeah, so the best way to know about that is follow us in Twitter. You will see that we tweet a lot about the papers that use Kornia. Yeah.
Great. I think we're about time to do trivia, or should we do one more question?
We should do trivia, but let me explain what people are getting.
Yes,
the box
please.
again.
Satia,
I told you that I'll open the box. I told you that I'll open the box, but I still can't show you the device. The reason is that we just want to keep it under the wraps for some more time. But just to give you an idea how small the device is, can you see the box?
Yes.
Okay. So it's like half the size inside, right? That's the case inside, and it is half the size. I have the device with me right now, and I can actually hide it right behind my fingers. So it is right there behind my fingers. So you get the sense of how small this device is, and very, very capable of spatial AI, right? So, but that's the prize for whoever answers the question today. The only thing I would say is that, we don't have many of these devices already built. The Kickstarter campaign will go live on September 15th. And whenever the Kickstarter prize winner, Kickstarter backers get their device, you will get your device at that time. So it will be slightly delayed a couple of months.
Yeah, Michael in the chat here asked, like a TARDIS. No, Michael, it's sort of a reverse TARDIS. It's smaller on the inside than the outside.
Right.
So for those of you who are just joining us, this is maybe your first episode of the webinar. The way this works is I'm going to ask a trivia question taken from Edgar's slides. The first person to answer it in the Zoom chat window on my screen will win what Satia just teased you with.
Not sure.
I love also, I'm a big fan of the Satia hand for scale. I think we need to make that a standard. It's like the new banana for scale. So during the presentation, before the example slides, Edgar had 3 slides showing specific domains where Kornia is being used. What were these 3 domains? Ooh, I think I stumped you. Finally. We need all 3, folks, all 3. This is good. I did it, Satia.
All right. I mean, it's better than 1 second response or, half-second responses.
Finally. Oh, you're so close. Everyone's getting 2 out of 3. Oh, so close. You got it. You got it. I think I see David.
Yes.
I think I see David got it. Farming, robotics, and IoT is the answer we were looking for, folks.
All right.
Thanks so much.
And they will receive the thing in the box, which I did not show.
What's in the box? Do you want to take us home, Satia?
Thank you so much, Edgar. It was a pleasure talking to you. I want to explore Kornia myself. I've been hearing so much about it. And, this may be the time that I dive into the code and get my hands dirty with it. And I'm sure that people listening to this webinar, they will be very interested in this library as well. So thanks for joining. And thank you, Phil, for organizing this. I wish all the best to Kornia. Thank you.
Yeah,
Thank
thank
you
you
all.
so much for the invitation.
Yep, and join us again next week. Next Thursday will be a look back at the winners of OpenCV AI Competition 2021 with our special guests, Brandon Gillies and Anna Petrovacheva.
Thank you.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Visit opencv.org/courses to learn from the experts. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.